Hello and welcome back. You might already know that nuclear power plants and nuclear weapons produce what's called nuclear waste, a highly dangerous material because it contains radioactive substances that can cause cancer or even death. Although humans have developed various methods to dispose of nuclear waste, there seems to be one brilliant idea that remains unexplored. Why don't we gather all our nuclear waste, load it onto rockets, and launch it straight into the sun? At first glance, this sounds dramatic but exciting. However, in reality, this is a terrible idea. To understand just how bad it is, please hit like to fuel this video until the very end. If you think nuclear waste is just contaminated gloves, tools, or rags with low levels of radiation, then you're mistaken. Those items are only classified as low-level waste, which makes up over 90% of total waste by volume, but contains less than 1% of its total radioactivity. Most low-level waste doesn't require shielding and can simply be buried near the surface. Next, accounting for about 7% of total volume, is intermediate level waste, containing about 4% of total radioactivity. This includes resins, sludge, chemical compounds, metal reactor fuel casings, and materials contaminated during reactor decommissioning or medical radiation therapy. Intermediate level waste usually requires shielding, but not active cooling. Depending on its half-life, it can be disposed of via shallow or deep burial. More dangerous is transuranic waste, any radioactive element with an atomic number equal to or greater than 92. The atomic number of uranium. These are mostly created during nuclear weapons production, such as americium-241 with a half-life of 432 years, and some isotopes of plutonium. This type of waste must be buried extremely deep, from 200 to 1,000 meters underground. The Waste Isolation Pilot Plant in New Mexico currently stores transuranic waste at depths of up to 660 meters. Finally, the most dangerous and long-lasting type of waste is high-level waste, mainly spent uranium fuel and fission products. Even after being used in reactors, these materials remain extremely hot and highly radioactive. Although they make up only 3% of the total waste by volume, they contain about 95% of the total radioactivity. They require both heavy shielding and active cooling. Some isotopes, like cesium-137 and strontium-90, have half-lives of around 30 years. Others, like plutonium-239, take 24,000 years to decay by half. Not only does high-level waste last for millennia, but it's also deadly, emitting lethal doses of radiation even in short exposure. Times, for example, 10 years after removal from a reactor, spent fuel still emits more than 10,000 rem-R. Just to give you a sense, a whole body radiation dose of about 500 rem is enough to kill a person. If these radioactive isotopes leak into groundwater or rivers, they could enter the food chain, exposing large populations and increasing cancer rates. Currently, most spent nuclear fuel is stored in spent fuel pools, thick concrete structures lined with steel, filled with water about 12 meters deep, which serves both to shield radiation and cool the fuel rods. When these pools approach capacity, some fuel rods that have cooled down for at least 5 to 10 years are moved into dry cask storage. Large steel containers surrounded by concrete, designed to last about 40 years. As of now, there are approximately 440 operational nuclear reactors worldwide, collectively storing around 400,000 tons of spent nuclear fuel since 1950. Including 120,000 tons that have been reprocessed. That equals about 20 to 1,000 cubic meters. roughly the size of a football field covered in 3 meters of nuclear waste. So with all this massive amount of radioactive waste, launching it into space, specifically into the sun, sounds amazing, right? The waste would be incinerated under the sun's extreme temperature of 5,500 Celsius and become part of it. We wouldn't have to worry about leaks anymore. But is this something we should do? Could we do it? Or even should we do it? Probably not. Let's break down why. 330, the first obstacle, and probably the biggest, is money. Launching anything into space is incredibly expensive. How much exactly depends on the rocket used. For example, the cost to launch 1 kilogram into low Earth orbit below 1,000 kilometers altitude ranges from $1,500 using SpaceX's Falcon Heavy to $178,000 if using older Delta IV rockets from the 1960s. Today's average is around $10. 0 per kilograms, or about $20 million per ton. That means launching all 400,000 tons of nuclear waste into space would cost around $4 trillion USD, or nearly 100 quadrillion Vietnamese Minh, almost 10 times Vietnam's entire GDP in 2023. No president or head of state wants to hear a number like that, even if money wasn't an issue. We don't have enough rockets. A modern heavy-lift rocket can carry between 50 to 100 tons into low Earth orbit. To launch 400,000 tons into space, we'd need anywhere from 4,000 to 8,000 launches just to get it into orbit, which is only 1,000 kilometers away. But the sun is 150 million kilometers away. And here's another challenge. Launching into the sun isn't as easy as it sounds. It may seem logical to send something into the sun. After all, it's huge, over 100 times the diameter of Earth, and has immense gravity. Surely anything launched toward it would fall right in, right? Well, yes, if Earth were stationary in reality. Earth orbits the sun at a speed of about 30 kilometers per second, or 108,000 kilometers per hour. So anything you throw directly at the sun will actually miss due to Earth's sideways motion. To make a spacecraft fall into the sun, you'd have to cancel out nearly all of Earth's orbital velocity, almost exactly 108,000 kilometers per hour, in the opposite direction. If you miscalculate and fail to precisely match this speed, your rocket won't fall into the sun. It'll end up in an elliptical orbit around it instead. And guess what? Now you've created a new radioactive asteroid drifting around the solar system. To put this into perspective, the fastest spacecraft ever launched, New Horizons, left Earth at only 58,000 kilometers per hour, or 16.1 kilometers per second. That's barely over half the required speed needed to cancel Earth's orbital velocity, 610 interestingly. Although it sounds counterintuitive, it's easier to leave the solar system than to fall into the sun. Mars, for example, orbits the sun at 24 kilometers per second, while Mercury, the closest planet, travels at 47 kilometers per second. That means the closer you are to the sun, the faster you're moving, and the more energy you need to cancel that movement and fall inward. In fact, escaping the solar system from Earth requires a minimum speed of 16.6 kilometers per second, known as escape velocity. That means you need less energy to send a probe to the stars than to drop it into the sun. There are no cops in interstellar space, so maybe it's worth it. But let's consider an alternative. To save fuel, space missions often use gravitational assists, commonly referred to as slingshot maneuvers. Spacecraft fly close to planets to use their gravitational pull to gain speed and change trajectory. This method has been successfully used by probes like Voyager 1 and 2, Pioneer 10 and 11, and New Horizons, However, even with this technique, launching thousands of tons of nuclear waste into space would be a monumental task. Each rocket carrying nuclear waste would need to be larger, better shielded, and far heavier than anything humanity has ever built. And don't forget, we're talking about highly radioactive material. What happens if a rocket explodes before reaching space, even the most reliable rocket in history? Russia's Soyuz, with a success rate of 97%, still fails 3% of the time. If those failures involved conventional cargo, it would be tragic. But if they involve nuclear waste, it becomes catastrophic. Imagine launching 50,000 Soyuz rockets, each carrying 8.2 tons of waste, and expecting 1,500 of them to fail, spreading over 12,000 tons of radioactive material into the atmosphere, land, and oceans. That would doom future generations to live in a world contaminated by our own disposal attempts. Even if the rocket explodes in space, the consequences are dire. Larger pieces would eventually fall back to Earth, burning up in the atmosphere or crashing like meteorites with the force of thousands of tons of TNT. Smaller fragments, millions or even billions of tiny particles, would float in Earth's orbit, threatening satellites, space stations, and future crewed missions to the Moon or Mars. So, is sending nuclear waste into the sun a good idea? Probably not, even though it sounds poetic, throwing our trash into a giant cosmic furnace. The risks, costs, and technical challenges make it impractical and potentially catastrophic. Instead, scientists are working on safer alternatives, advanced reprocessing techniques, next-generation reactors that reduce waste, and deep geological repositories like Finland's Onkalo facility. Still, the question remains, what's the best way to handle humanity's most dangerous legacy? Let us know your thoughts in the comments below. As always, don't forget to like and subscribe to the HeckyFish channel, and hit the bell icon and never miss another weird and wild science video from us. Goodbye for now. See you next time.